Hey guys, we're going to talk about consciousness in this lecture series. Um, this is really the beginning of where we're going to start talking about dreaming, and to understand a lot about dreaming and that sort of level of consciousness, we have to talk about consciousness as a whole. So just to kind of give you a sort of a brief overview of consciousness, the problem with consciousness and the whole idea behind it is that no one can actually agree on exactly what it is. So it makes things really complicated when you're trying to not only study it, but try to define it. So depending on who you ask, what kind of scientist, whether it's a psychologist, a sleep scientist, a doctor, a medical doctor, a physicist, a mathematician, everyone has their own definition of what consciousness is. And what you'll notice is you can get 15 different books about consciousness, and it will actually give you 15 different definitions. Um, so each discipline, each book, each scientist, everyone has their own idea of what consciousness might be. And nobody has a really solid definition of exactly what it is. And that makes it even harder to study, because if we can't define it, then we can't measure it. If you're interested in heart rate, for example, you find a way to measure heart rate. And then you can have a standard measurement, and every single time somebody talks about heart rate, they're measuring it the same way, and that can compare across many different people. When you have something like consciousness, if nobody agrees on how you can measure it and what it is, then it's very difficult to have something across the board that everyone is able to use as a measurement, everyone's able to use as a standard. So what I've got here is a basic definition. This is a broad definition. Not everyone would agree on this particular one, but I think it encompasses consciousness to a degree that is a pretty solid definition. And that is that consciousness is an awareness of, an ability to communicate about one's thoughts, perceptions, memories, and feelings. And so, and I just realized that there's a typo on here that one should be possessive. But anyway, you get the point. So really, this is the awareness of your surroundings, awareness of your perceptions, awareness of your feelings, your emotions, and also being able to communicate. So the issue with consciousness is that we start it. When we talk about normal consciousness, it starts getting more complicated when you look into special cases. So for example, would you be conscious of, for example, you're driving down the road and you see something happen, right? You physically see it, but you don't realize that you see it, and you react to that. So what can happen a lot of times, people will say that they're kind of, they have intuition, and they may say, well, I think that a cop is around the bend, right? So you're driving down the road and you think, oh, there's probably a cop nearby. I bet I should slow down. Well, what if instead of you being able to tell the future, and let's say you drive around the bend and there is in fact a cop, perhaps you picked up on clues around you without really being aware that you picked up on those clues. And let's say you noticed the people around you were that coming the opposite way were slowing down. Maybe you just so happened to catch a glimpse of it and didn't realize it. Maybe you caught a glimpse of the headlights or the blue flashing lights, and you didn't realize that. Maybe you picked up on some other clues around you that you did not kind of put into awareness, but it was enough for you to get that gut feeling that you should slow down. So this would be an argument. Were you conscious of this? You were able to change your behavior and to change your action and to slow down, but yet you couldn't really verbalize that you saw these things. So when we talk about consciousness in that sense, it's difficult to say, okay, well, what is true awareness? Now, there's also been conditions, which we'll talk about in just a minute, that really test our definition of consciousness. We have conditions where people seem like they should be aware of something and they react, but yet they don't consciously say, they can't verbalize that they are aware of those things. And we'll talk about that in just a minute. Another thing is it starts getting complicated when we look at cases of, for example, being in a coma. There are different stages of being of awareness in a coma. You can have this stage of awareness essentially where you hear things around you, but you're not able to communicate that. You're aware, but you're not able to communicate your thoughts, your feelings, what you're hearing. You're not able to respond. So we can call this locked in syndrome. And this actually does occur where people are essentially locked into their body, and after perhaps an accident or a condition or a infection, and so they look like they're a vegetable. They don't respond to any cues. They don't physically respond with their eyes. They can't respond with reactions with their body. But yet they're conscious, because when they're able to wake up, and if they do wake up, they'll say, I remember everything. And they'll actually relay a lot of information that was done to them or said around them that they could not have known otherwise. And these are very rare cases, but they really challenge our definition and our understanding of consciousness. We also see cases where people have realized this, scientists have realized this, and so what they'll do is they'll take a person who is in either a brain dead or a comatose state, and they'll put them in an MRI scanner, and using fMRI or functional MRI, we'll try to see if people are reacting, their brain wise, their blood flow in the brain are reacting the same way that or similar way that an alert person will react to different things like pictures and to physical touch and things like that. And so that has actually provided us an opportunity to kind of recognize those who are that do have locked-in syndrome, that they're in some level of conscious of what's going on around them. They're just not able to communicate that. So this definition is complex. This idea of consciousness is complex. Edelman is a very famous neuroscientist who described consciousness as a sort of remembered present, and believed that this self-awareness is what we refer to as an immediate memory of how we are feeling, what we're thinking in the current moment. But again, not everyone agrees on these sort of definitions. Now, blind sight is a condition that allows us a little bit of insight on consciousness and kind of changes our perspective on what consciousness is. Now, blind sight can occur when you've got some sort of trauma to the brain. So it tends to occur, for example, after a brain tumor, more commonly after a stroke in a particular area of the brain, or there's been trauma damage to the area, to this very specific area. And so there's a video that I've loaded on Moodle that I want you to take a look at, because I feel like when people hear me describe this, they don't really believe that it's actually a thing, but it really is. And so essentially what it is a person can be, after this trauma, can either be completely or partially blind. And in some cases, they are completely blind. They cannot see. They might be able to see light, but they don't see things. They can't see. And so essentially what happens is that a person cannot communicate that they are aware of anything. Okay. They don't see anything. They will say, I am blind. But if you throw a ball at them, or if you ask them to touch something in front of them, they will actually be able to do it very accurately. So if you put in in the video, they have this in the video, essentially putting up a course of obstacles, sort of an obstacle course, where a person has to navigate around that. Now, these people are blind. This person is completely blind in the video, and yet they're able to stop in a completely new obstacle course. They've never been in it before, so they can't memorize it. They actually stop and are able to maneuver around objects in front of them. And you ask them, well, did you see that? You walked right around it. And they'll go, no, I just thought that maybe something was there and I should walk around it. I just walk this way. So they can't even verbalize. They are unconscious of the perception of what's going on, but yet they're getting some input into their brain because they're able to dodge things. They're able to catch balls. They're able to, touch objects that are held out in front of them that they say, well, I'm blind. There's no way I can do that. And then they do it. And so they're usually very surprised at this ability. So the question is how does this work? Where does this come from? And so we have here two. This is a really interesting sort of breakdown of the two visual systems that we have a theory about. So essentially, one is our primitive visual system, and this is a system that moves from the eye throughout the brain. And so this very, very primitive visual system is just picking up on the absolute vital things that are really primitive behavioral mechanisms that we use to survive. So if you look at evolution of the human brain, this would be a system that would have been evolved the longest ago. Okay, so this is a very old system that our eyes and brain have relied on for survival. So these are things like eye and head movements, reaching movements, very simple behaviors, just so that we can navigate our environment. Very basic stuff. So if you do not have damage to this particular visual system, then you have the potential of being able to still use these very primitive mechanisms in order to navigate your environment. Now, the more recently evolved, the more recently and more advanced visual system is the mammalian visual system, which evolved as mammals have come into the earth. And so essentially what this is our awareness level. Okay, this is we have speech and thinking put together into conscious, being able to talk about what we see, being able to recognize, oh, that is I see this thing in front of me and it's blocking my way. Very complex behaviors that are associated with vision, in the sense that we put into communication what we're in order to put it into communication, or in order to be able to communicate it, it has to be in our sort of perceptual awareness. And so if you have damage to this mammalian visual system, but not the primitive visual system, this is where we think that blind sight's coming from. It's a very interesting phenomenon, and I really encourage you to watch this video. But this condition has really changed our perspective on what consciousness is, because technically, if you can't put it into awareness and if you can't communicate to it, are you conscious of it? You're still able to change your behaviors and you're still able to, move around an obstacle or whatever. But does that mean that you are conscious of it? And according to the definition, this is maybe a potentially a different level of consciousness. So this, I have a couple of examples here. The top link is really good about sort of understanding what's going on, and the bottom link is the example of the man actually doing the obstacle course, and the man is blind. And I think the bottom example is a separate link on Moodle. So this just kind of gives you a basic sort of idea of how the visual system works. Now, I know that we didn't get, you guys had slides on the brain and what brain areas were important, what brain regions are important for sleep. But I just want to remind you guys that the brain is contralateral. Like a lot of behavioral functions are contralateral in the brain, meaning that the right side of your body is really controlled by the left hemisphere in the brain, and the left side of the body is controlled by the right hemisphere in the brain. And this also occurs for eye input, for visual field input. So if you see on this picture here, you can see where the eyes cross. So the red area, you can see the input crossing over into, one side of the brain, and then the blue side is showing you the pathway to the other side of the brain. And the brain is it's really essentially split into two halves, and these halves have to communicate to each other. And so the eye input goes through a nerve that crosses over at the optic chiasm, and you can see it right at the crossing point from the eyes. And so it crosses over this particular area and into the corresponding brain hemispheres, and then communicates throughout the brain so that the whole brain can understand what you're looking at through both visual fields from both eyes. And so it's able to communicate this information to itself and give us a perspective that covers our whole visual field. Now, when you disrupt any of this, of course, you can have damage in vision and damage in what you're seeing, and also what you're able to be aware of. And so this is just kind of a reminder, and also, an explanation of how the hemispheres are processing that visual information. So here you can see that the brain has a structure in the middle that's called the corpus callosum, or bridge between both hemispheres, that allows for communication between the hemispheres. So it allows whole brain communication. Now, we have what's referred to as localization of particular things that the brain does. So localization means that there is a particular area of the brain that's localized to really house a particular ability, okay? So we use our whole brain for everything, but there are some things that are just really specific to a particular area of the brain. For example, speech. If you damage a very specific part of the brain, you're going to very likely damage your ability to speak or comprehend language. There are other particular areas, for example, in the back of the brain, where if you damage those particular areas, then you're going to have problems with vision. You may not have problems with input of vision, as in your visual field is technically intact, but your processing and awareness of what's in those visual fields, because it's in the occipital lobe in the back of the brain, that's going to be affected. Just to give you an example, if you have a stroke and that stroke is in more towards the back of your brain, you may actually become blind in a particular area of your visual field. So the input is fine, but the output is not fine. And so if you damage or cut the corpus callosum, what you're doing is you are removing the communication, the structures, the tissue that allow communication between hemisphere to hemisphere. So you're still getting input in. So if everything's intact for your brain, you're still getting input in, but because the two hemispheres cannot communicate, you're going to have difficulty with certain tasks. It may be that you can see one thing but can't communicate that you see it, or that you realize that something's going on but you're not able to verbalize it. And so what this is an explanation of a particular procedure called the split brain operation, which is done for people who experience very severe seizures. So a seizure is essentially when you have overfiring of neurons in a particular area of the brain. If you have, for example, damage, let's say you smacked your head really hard one time, or you got in a car accident, or you got hit by a car, and you smacked your brain, or you played sports and you had a really severe concussion and had some brain damage, what can happen is scar tissue can develop. And that scar tissue becomes much more vulnerable to having problems with the neurons. And so what can happen is people can go all their life never having a seizure, then bump their head and then have scar tissue form and actually start developing seizures in that particular area of the brain. Others have what we refer to as epilepsy. In some cases, we have no idea what causes it. They just tend to have seizures. And you can have very small seizures where it's like very mild, and you just sort of stare off into space, to the very, very large grand mal seizures where you're, seizing on the floor, and you're sort of and then you lose consciousness. And so, and it ranges all in between. And so having a seizure actually puts you at risk for having another seizure, because sometimes that can actually damage and create scar tissue, which means that, that makes you more vulnerable to seizures in the future. But there are some individuals who have such severe seizures. I mean, they could have hundreds of seizures in a week, and every single seizure you have could kill you, because it could damage your brain to the point where you can't recover. We don't typically see that a seizure is going to immediately kill you, but of course, that does, depending on what area of the brain you have a seizure in, it can damage and you can reduce function. So some individuals, what they do is, if they know that they have a seizure, their seizures are crossing over from one hemisphere to the next. So sometimes seizures are sort of localized into one particular area of the brain. Sometimes it'll just fly over to the other side of the brain and really, really impact function and quality of life, and take away things like being able to walk properly, being able to eat, things like that. Some individuals get very desperate, which makes sense, and have to have a surgery where the doctors will cut their corpus callosum, because what that does is it stops the seizure from traveling from one hemisphere to the next. And in some cases, it dramatically reduces seizures. In other cases, it actually gets rid of them completely. It just depends on the case. And so it's a very radical procedure. It's not something that, you have a seizure once and someone goes, okay, well, let's go ahead and do the surgery. It's usually something that, takes a lot of thought, and it's because you've tried medication, you've tried everything, and nothing else works. And so this is a very serious brain operation where those two hemispheres are essentially disconnected. Now, I really want you to take a look at that video, because it gives a much more detailed explanation of the split brain procedure and how that really impacts our understanding of consciousness. Because we have this idea here where we have the two hemispheres that are communicating, and through the corpus callosum, you cut that structure. And now what happens? You're losing the ability of being able to communicate certain things that you see. You lose this element of awareness. And, you ask yourself, is this still consciousness? Even though you are able to behaviorally change your behavior, is this still a level of consciousness? So it's very interesting to see what kinds of things happen when you cut this corpus callosum. And the video goes into some really interesting experiments that have been done to show the kinds of issues that individuals have when they've had that communicating structure cut. So when we look at different levels of consciousness and we look at sleep, we know that the different stages of sleep and the different types of sleep and wakefulness are all different. We know that they're all different. And we know that there's still a level of consciousness that we have to have while we sleep. Because if a sound, for example, is loud enough, it can wake us out of a sleep. Well, if we are completely unaware of our environment to the point where we are completely shut off, then that means that there is no awareness there. There's no ability for us to process information. And then that doesn't make sense, because, there are times where we hear a sound that wakes us up, smell something. For example, if you are in a house fire, and some people are awoken by the smell of smoke or the sensation of heat. Or sometimes, and this has happened to a lot of people, and I'm sure some of you can probably relate, you might be in a situation where you actually hear somebody talking or moving around, and you dream it in a dream. So you may take the information that's going on around you and incorporate it into your dreams and incorporate it into your sleep. So there's still some filter that's going on and some level of awareness that happens while we sleep. And this makes sense because we want to make sure that we have some level of awareness, because you want to be able to react if needed. So if your life is threatened, you want to make sure that you can awaken out of a sleep and react. But when we look at REM, for example, REM sleep, which is the type of sleep that you're more likely to dream and have very vivid dreams, and wakefulness, we know that they're very similar in terms of brain waves. It looks very similar, but the difference is, of course, the paralysis that we see in REM sleep. So there's a difference in the level of sensitivity to external stimuli. There's a difference in terms of memory, what you remember and what you're able to process. And then when we look at REM by itself, we see these things called late potentials, or P300 waves, not being present during REM sleep. And so these particular P300 waves are measured by EEG, and this is something that is essentially our reaction to stimuli. And so when you don't see the reaction present, that's telling us that there's something that gets shut off in terms of consciousness, or at least dialed down, greatly reduced, for us not to be able to react to stimuli like we do when we're awake. When we're awake and we have people doing reactions to different things, we see these P300 waves through EEG there's a couple of different measurements here, but looking at these potentials through EEG, while a person is awake, we can see their reaction happening, and we don't see that in REM. Now, also we see a difference in brain activity in terms of cerebral blood flow. So there's the theory that MRI really is dependent on, is that when you use a particular area of the brain, because our brains do not have an energy store. So like our bodies have an energy store in fat, right? So we store our energy, our cells can store energy, but in our brain, we don't have a storage, okay? People don't have fatty brains. We just don't have fat in our brains. We use energy as needed. And so one way that we use energy is through glucose, and oxygen that's delivered through the blood. And so when we're using a particular area of the brain, you see an increased amount of blood going to that area to supply it with the oxygen and glucose that's needed to convert to energy, so that way the brain can function. And so MRI measures that. fMRI measures that. That's what it's looking at. It's looking at the blood flow that's going to the brain, and our theory is that when we have an increased blood flow, that we're using that particular area of the brain. And so when we look at the brain and the blood flow in the brain while you're asleep, when you are in REM sleep, we see the visual association cortex having a lot of activity. But what's interesting is not always what areas of the brain are being used, but what areas of the brain are not being used. And so we see not as much blood flow in the primary visual cortex and the prefrontal cortex. Now, the lack of activity in the primary visual cortex makes sense because our eyes are closed and we're not getting visual input in from our outside environment. And the prefrontal cortex is not as active. And that's important in things like decision making, but also being able to distinguish reality from illusion, being able to process what's real and what's not. And if that area of the brain is not acting on all cylinders, then what happens is that we get these dream states where they just don't make sense, right? So you're not able to tell yourself, oh, it's just a dream. Oh, this is just happening. This isn't real. In the moment, you believe it's real. And that's why some dreams can be so incredibly vivid and so story-like, even though you wake up and you think that doesn't really make sense. but it did in the moment, right? You might see a person in your dream that doesn't look like someone, but you see them as someone. And all of this makes sense to you in the moment, but the prefrontal cortex's job is to tell you it's an illusion and it's not working in the moment. We also see this sort of pattern activity occur in hallucinations, but it's a little bit different in terms of what you're seeing activity-wise, but it's the same idea. The prefrontal cortex, its job is to tell you this isn't real. So it's almost like you're hallucinating while you're sleeping. And it's very interesting to see, kind of what's going on in the brain while you're dreaming and how you're processing this. There was this theory before about eye movements during REM sleep. The eyes are moving back and forth very rapidly during REM sleep. And so there was one theory at a certain point that if you track the eye movements, that is pretty much going to be what you're dreaming. So there was an idea that, your eyes are moving back and forth. You must be dreaming about a tennis match and you're watching the tennis ball go back and forth and back and forth. And there's been a lot of conflicting evidence about, is this really true? And do your eye movements really match what you're looking at in your dream? It's very difficult to study, and there doesn't seem to be any definitive, absolute, yes, this is what's happening. It seems to be rather mixed in terms of data. Now, this last thing I want you guys to look at is these are three very different perspectives of consciousness, going from a philosopher who is also has a cognitive scientist view, to a mathematician or a mathematical physicist, to a neuroscientist. And each of these each has their own sort of merits, and each, has their own sort of particular perspective on what consciousness is. And this is what I really want to make sure that you understand, that each field, each scientist has their own idea of what consciousness really is. And so you can see how they differ among each of these three, looking at a philosopher versus a neuroscientist, for example. Very interesting, different perspectives. So if you have any questions, of course, you can email me. Use the question form to your advantage. If anything seems confusing, or if you're just not sure, or things seems kind of odd, especially as we start getting into this, talking about dreaming, this can really get when we talk about the theories, this can really get confusing. So make sure that you're using the question form to your advantage, and asking those questions to clarify any material that you may have difficulty with. So good luck on your test this week, and let me know if you have any questions.